Hope my screen is visible.
Yes, sir.
Okay. In our previous class, we were looking upon the grid computing and the difference between grid computing and cloud computing. We will see after a couple of concepts are cleared with respect to the cloud computing. The next concept, very important concept with respect to the cloud computing, is called as virtualization. Just look into the picture, pay attention to the picture and see what you can make out from this particular picture. Take a minute, understand the blocks given in that particular diagram. There are two different architectures. One is the traditional and other is the virtual architecture. Okay, fine. Let me move on to the next slide here. Now, virtualization. Now, let us discuss on this particular concept, virtualization. Now, what do you know about it? What do you know about virtualization? When you hear the word virtualization with respect to the computing stuffs, with respect to the computers or any electronic digits, so what strikes to your mind? It could be any example where you have used it or where you what you know about it. So anything related to the virtualization, I want to hear from your side.
A space or that doesn't exist, but it is there.
A space which doesn't exist but it is there. Okay. Mhm.
Virtual operating systems.
Virtual operating systems. Okay, good. Hmm. What else? Anyone wants to add upon those two couple of points? Hmm. Yeah, as you said, the something which is there but doesn't exist, right? Yeah, we can. It is kind of a metaphor for that, for the virtualization, right? And the second one, what you spoke about, it is something wherein the operating system, virtual operating system. Okay, can you tell me more about virtual operating system? What you mean by that? Probably example where you have, if you have used it or if you have seen
VMware operating systems. VMware.
VMware. Very good, right? Now try to whenever what the concepts which we are going to discuss now, try to think or visualize with respect to the VMwares now. Okay, because you all have used VMwares. VMware is nothing but virtual machine web based. Okay, now let us quickly go and see what actually virtualization means. Virtualization refers to the creation of virtual resources such as operating system, files, storage, or a network, right? Now, one example you talked about, that is operating system, creating an virtual operating system. So virtualization not only can be done for the operating system, but also for the files, storages, and networks, right? So virtualization means here is that it is something exists, it is there, but we can't physically identify that particular thing on a hardware. Okay, that we can something call it as an virtualization here. Okay, sometimes we call it to be a virtual network, right? Most of the time the private organization makes use of a virtualization network, or sometime it is something like there is a public network, there will be a public network. In that particular public network, there will be a subset or a submask created which will be restricted for the access by from the other end users. So only the limited or the identified users will be able to get access to that particular network. Okay, so we can call it to be a kind of a virtualized network which exists, which is there but doesn't exist, right? Now we have seen four examples there, such as like operating system, file, storage, and or the network. Out of these four, what do you think which is the most common type of a virtualization we can have for? Is it for a network, or is it for a storages, or is it for the file, or is it for the operating system? For which of the type from above these four we can have a most common form of the virtualization? Any guesses? I actually got disconnected for a moment. Uh, 1 second. Are you able to hear, students, my voice? Is it audible?
Yes, sir.
Okay, I got
Yes,
disconnected
sir.
a few seconds. Okay. Now, the most common type of the virtualization is for at operating system level, right? So operating system level virtualization is the one of the most common type and more familiar, and most of the time the companies who are providing certain applications in the virtualization field are with respect to the operating system level. So what actually happens in the operating system level virtualization is that we can run multiple operating systems on a single hardware. So running a multiple operating system on a single hardware, what actually we mean by that? Does anyone know about the last point? It is possible to run
Yes,
multiple
We
operating
can
systems.
create a virtual space and boot different operating systems, sir.
Yes, very good. We can host multiple operating systems on a single hardware or a, suppose the best example I can give you for is the in our lab, all our systems, right? Whatever you systems you use, all are having a VMware, right? The physical hardware we have only one, right? The hardware has a master operating system or a base operating system. We can call it to be a Windows operating system, right? On the Windows operating system, we have installed certain application, right? That application is VMware. So now VMware allows us to install or host, to be more precise, to host other operating system within that particular application, right? So that concept we call it to be a virtualization level as per the operating systems, wherein we are creating multiple operating systems and we can host on top of another operating system, right? So the hardware used for that is only one hardware, but we can access multiple operating systems. It's like even say on the virtual VMware or a VMware, or it could be a virtual box, right? It's need not to be we can host only one OS there. We can have a n number of operating system. Like one can be a Ubuntu, another can we can host one more simultaneously as a say a Fedora operating system, or even we can have another Windows operating system into it. Right? It doesn't matter. It we just need to have a supported binaries for that, okay, wherein we can just host on the applications. So the most common type of the virtualization method we use is the operating system level virtualization. That usually we call in a term virtual machine. Virtual machine is a common term or the a terminology we use for hosting multiple operating systems on a primary OS. Primary OS means the other word I used earlier was the base OS, right? So that is the virtual machine. So in the context, the further context, whenever we come across the term called as a virtual machine or VM, that indicates that it is an operating system level virtualization, wherein on one particular operating system, there is an application hosted and that application allows to host multiple operating systems. Am I clear here?
Yes, sir.
Okay. Now, so what is so special about this particular VMware or sorry, what is so special about these virtual machines? I personally, I treat it to be a kind of a magic for us. What is so special? Can anyone answer? If we can host multiple operating systems on our single hardware, that is, if we can have a virtual machines, then what is so fantastic about that? What it makes special? The answer might be very. Anyone trying to answer?
the fact that it
Uh,
can run already on a machine that has operating system and is not going to affect the other operating system in that machine.
Yes, correct. That is correct. Someone else?
we can But like she said, we can run more operating system on a single machine. We
Mhm.
don't need other machine to see the environment or test the environment for
Mhm.
that OS.
Yes. So in one point, whatever we discussed, couple of points here, in single line, if I want to tell, it is like the VM machines, the virtual machines are treated like a normal file. Can we say that? The
Yes, sir.
the virtual machines are treated like a normal file. So what? Normal file, so what? So what means, if suppose if I have a virtual machine, it is nothing but a file. That file I can take from here and I can copy onto a pen drive or I can copy onto a hard drive and give that particular file to someone else. And that someone else can take that file and put it into their machine. And when they invoke that instance of that particular virtual machine, it looks the same as what I have here, right? Isn't it a copy and copy pasting a simple file, a normal file from one particular computer to another computer? It does behave exactly same. If suppose if someone creates, suppose you have experienced this, right? In our lab we have the virtual machines, and you have probably in your previous semester you might have requested lab instructor to provide the virtual machines, the software along with the VMware instance of that particular operating system. So what you could have done, initially you would have installed the VMware application and then just loaded that particular file, right? So when you load that particular file in the VMware, what happens? It just creates or hosts that particular operating system. It is like a normal file. It can be copied from one system to another system, just like a normal file. That is the one of the most advantage of the virtual machines. Like entire operating system can be copied from one system and put onto the another system. Is that fine? Okay, then why we are looking into the virtual machines or virtualization with respect to the cloud computing? What is so why this is particular virtual machine or the virtualization concepts or the technologies are important in the cloud computing architecture? Anyone knows about that? Your thoughts on that? I would say that okay, virtual
Sir,
machines.
because entire cloud computing is based on virtualization.
Yes, the entire cloud computing is based upon the virtualization. The service provider need not to have a different hardwares for the different requirements of the users. Suppose today one user is there, he is demanding for a Windows operating system is so and so configuration. Suppose if the service provider doesn't go with the virtualization technique and just follows the traditional technique or the architecture, what he will end up in having a different hardware, and on that particular different hardware he would host or he would install Windows operating system. Later some one more user will come and he would demand for what? I require an Ubuntu operating system, and so with so and so configuration and certain softwares. Then again, what service provider has to do, if he is not following the virtualization, he has to buy one more standalone hardware, and on that top of that particular hardware he has to install Ubuntu on that. So it makes the life of or the cost of the cost at the service provider will increase. Instead of that, if the service provider thinks that okay, why can't I go for an virtualization technique wherein I will use a huge size of a hardware. Huge size I mean here is that the hard disk of that particular machine would be in multiple terabytes, and what he can do is that he can just put up a layer of a virtualization layer in that, and whatever requests are coming up, he just try to create an instances of those particular operating systems and give the access to the users, by which the service provider would be saving a lot of time. And the at any time, if it is said that the user doesn't require that particular operating system or the services, he can just simply delete the file, that is VM file. So the maintenance activity will be very easy for the service provider, and at the same time he can save a lot of money in that. So that is why we are discussing upon the virtualization in the cloud computing, right? And there are two types of virtualization. One is full virtualization and second is para virtualization. Okay. Before I explain the theoretical concepts, these particular slides, let me jump on to a slide here because that would give you a more better picture about what a full virtualization and a para virtualization. Pay attention. This is important for the point of your examination, and also the concept. I want you to learn this particular or understand this particular concept of what full virtualization and para virtualization. 99% you are going to get a question on this in this particular semester for the final exam. Okay. Now, full virtualization. See here, just try to see what are the components are there in this particular diagram. You have bottommost the hardware. Then there is something called as an hypervisor. Okay. Then there is something as a guest kernel. Okay, and then you see a arrow mark from the guest kernel towards the hardware, which we can call it to be a privileged instruction. Okay, and then from the hardware there is another arrow towards the hypervisor, and we named it to be a trap. Okay, now understand these three different components here. The first one is the hardware. So hardware, you think that it is the base hardware on which we are going to have an virtualization. That means it is a single hardware. On that, we can install n number of operating systems. Then there is something called as an hypervisor. So this hypervisor, you can think that, okay, it is something which will allow you to make the or create the virtual operating systems. Let us think that this full virtualization with respect to the virtual machines, that is different operating systems. Now this guest kernel, it is nothing but it is a VM. It is a virtual machine. Think that it is Windows 10 and this is your Ubuntu. And the technique used to create this VMware is of a type of full virtualization. Now, when the full virtualization technique is utilized, first point is that the guest kernel or the virtual machine operating system doesn't know that it is a virtual, right? Pay attention once again. This guest operating system or a virtual machine, it doesn't know that it is a guest or it is a virtual machine. It thinks itself as it is a standalone operating system, right? That is the first point of about the full virtualization. Now, what happens in that is that suppose whenever the guest kernel or the operating system is trying to access the certain hardwares of the base system. Okay, suppose if it wants to access certain printers as an hardware, think like that. Okay, now when this is trying to access certain hardwares, it has to call or invoke certain instructions. Those type of special instructions or a special hardware instructions, we call them to be a privileged instructions or hardware calls, or sometimes we can call it to be a kind of a hyper calls. We will discuss that later. Okay, now it is trying to have certain privileged instructions wherein it is trying to access the hardware. Now, since it is the guest kernel is thinking that I am the boss here. It is thinking that I am the boss and I have access to directly hardware because it is treating itself that like a normal or a proper operating system. But in reality, it is not the case because it is a virtual machine. Now it tries to access the hardware. Now hardware knows about everything, right? Because it is the master. Hardware knows everything because what it knows that, okay, I have a base OS and on top of me, I have a different operating system installed, like a virtual machines are there. I got a call, right? It got what it says, I got a call from some instructions from the guest kernel to execute. Now it executes that one. Now what it does, since it knows that there is a operating system that is a VMware installed on that through the hypervisor, then the hardware can only communicate to the hypervisor, that is the mediator. It can only communicate with the mediator. But here, this particular mediator doesn't know anything about what the response the hardware is giving. because the request from the kernel has been bypassed directly to the hardware. The hypervisor was not made about what was the request originated from the VMware here or the virtual machine. But it is getting a kind of a response which it doesn't identify at all. So what it will do, hypervisor, it will just ignore that response. It will just ignore that response. So what we can call it that all those response will get trapped within the hypervisor itself. It will not go back to the kernel. So now here the guest kernel or the operating system think that I am sending certain requests to the hardware, but hardware is not doing that particular activity. So all those privileged instructions or the hardware calls will get suppressed, will get trapped within the hypervisor itself. This is one of the drawback of a full virtualization. But in certain cases, we make use of a full virtualizations in order to achieve certain other tasks. Okay, this is what we can call about the full virtualization. Is it understood, students? Please do let me know if you did not understand. Now, I think these three different components is, and you have understood. Initially, I told only concept you need to
Sir,
understand is that
can you provide an example with related to full virtualization?
uh, the best example I can think of is a printer here. Okay, the printer in if the virtualization technique if we use is of to be a printer, what will happen is that the full virtualization operating system will invoke the hardware, okay, to supply or to send some information to print, but that response will get just suppressed with the hypervisor. It will not send back to the kernel. That would be a best example for the full virtualization.
Okay,
Nowadays,
sir.
the virtualization layer, whatever we are getting, most of the virtualization techniques are from the para virtualization because there are a lot of problems with respect to the full virtualization. So the full virtualization techniques are not used most of the time, but in some cases, wherein specifically, okay, the VM machines, the virtual machines, if an organization think that VM machine should not get a privileged calls, okay, in some cases, in such cases, they will just go ahead with the full virtualization technique to host the applications or host the VMs. But in most of the time, we go with something called as an para virtualization. Now look into the para virtualization here. What is the difference you can think here? What is the difference here? What you can make out from this full virtualization and para virtualization? Can anyone make out? First is the guest kernel. Instead of guest kernel, we have something called as modified guest kernel. That is the first difference. Second is that the privileged instructions are called as hypercalls. The privileged instructions are called as hypercalls. The other one is that all these privileged instructions in the full virtualization were directly went or given to the hardware, not through the hypervisor. But here, the same privileged instructions, which we are calling them as another name hypercall, are being sent from or sent through the hypervisor. So all those calls initially will get sent to the hypervisor, and then this hypervisor send that particular instructions to the hardware. When the hardware does that activity, it will send back or the the responses will be sent to the hypervisor, and then it will be sent back to the modified guest kernel. Now try to understand what this it is. Here, the first point about para virtualization is that the para virtualization machines or the VMs which belongs to the para virtualization technique, they know that they are virtual machines, unlike in the full virtualization, right? If you remember in the full virtualization, what I said, the VMs treats themselves to be a normal systems. They don't know that they are a virtual machines. But here in the para virtualizations, the virtual machines know that they are virtual machines. When they, how they will come to know that they are virtual machines? Because the binaries of those VMs. When I say binaries means certain instructions or certain piece of a code of the operating system will be tweaked or will be modified, and such a way those operating systems or the binaries will be modified that let that operating system to be known as or to be treated as the virtual machines only. Means it knows that it is an virtual machine. Whenever if it wants to communicate with respect to the hardware, it's think that okay, I am a virtual machine, I can't send all the instructions or the hyper calls, the special the uh, uh, hardware calls or the special instructions will be treated as a hypercalls, and all those hypercalls will be sent to the hypervisor, not directly to the hardware. Now hypervisor, what it does, okay, it is getting an request from a so and so VM machine, and it will send that instructions to the hardware. Then hardware will respond it back to the hypervisor, and then hypervisor knows that response because it has received some request from the guest kernel, and then in turn it will give it back to the VM machine. Now virtual machine, the advantage of para virtualization is what here? All the hypercalls where are not getting trapped within the hypervisor, but are worked out properly by the hardware, and the responses are coming back to the virtual machines. This is the advantage of the para virtualization. Most of the virtualization techniques for the VMs is being taken care by as the para virtualization techniques, wherein the virtual machines know that they are virtual machines. Did you follow? Is it too much complex concept? I just need an acknowledgement.
No, sir.
All right. Okay. Because I just directly ran through this particular image without explaining those concepts, the slides, because I wanted you to make understand between what this difference is, how it looks. Then you can just go ahead and just read those particular slides. In both the techniques, we can host multiple VMs at a on a single piece of systems. But in your textbook, what they have given the image is of this one. This is they have given this for the full virtualization. Like you have a service provider, and you can on your particular machine as a user you can access an Windows operating system. If you look at here, the user is having Windows, whereas the service provider is having the Windows. It is like the base OS is Windows, and the virtualized OS, that is VM, is also Windows. It is not that the diagram depict to be that you can only install a single VM on that. It is not like that. We can install multiple VMs on the user side. Okay, but only thing is that if this is a Windows, the other one will also be a Windows only. If we want to have a third OS to be installed, that is also to be a Windows. How they can differ is that suppose if one is the Windows 10, other one would be Windows 7. Or if it is a one is the Windows 10 32-bit, other could be Windows 10 64-bit. Multiple instances can be created, but it is of a type of a Windows itself, same flavor itself. Okay, because of this drawback, the full virtualization technique is being taken out in most of the service providers. Even if you want to, if someone, the user wants to have their own individual VMwares, then also it supports para virtualization, wherein they can make use of multiple uh, type of operating systems. Look at here. Now this example is what base can be of any of the flavors like Windows. If it is Windows, then multiple of VMs can be installed of a different types, or the base could be of a Linux here, right? Linux flavor, and on top of Linux flavor, they can install any other type of a operating system. Okay, this is a diagrammatic representation, the pictorial representation of the full and para virtualization. If you just look at these diagrams initially before I explain, definitely you could have got confused between those. That's why I did not go through this one. And for me, personally, I will think that these diagrams doesn't give you a proper distinguish between the full and para virtualization. But in your textbook, they have given the same images. That's why I have taken those things. You can go through these particular points. Do let me know if you don't understand any one of them. These statements, these paragraph statements are directly being taken from your textbook. That's why I have given the same thing, because since this the textbook which is been prescribed is being followed by all other colleges. That's why I am using the same wordings there, because when during the examination they also expect, the evaluator also expect that the same points are written there. Okay, as an additional part, okay, you can go through this one later also. As an additional part, what I have done is that this difference table, the differences between full and para virtualization. In full virtualization, does not need to modify guest operating system, right? As I said earlier, if you remember, the binaries of the guest operating system is not been modified, but in the para, it is been modified. Then guest OS does not know that it is virtualized. Yes or no? In the full virtualization technique, the guest OS, when I say guest OS, it is nothing but the virtual machine. The virtual machine doesn't know that it is a virtualized. But whereas in the para, it knows that it is an virtualized, right? And all those privilege calls will get trapped in the full virtualization technique. But whereas in the para virtualized technique, those privilege calls, we call them to be a hardware calls or the hyper calls. Those are replaced with those particular hyper calls. When we say hyper calls, those will not get trapped. Rather, they will send through the to the hardware through the mediator called as hypervisor. Okay, a common and cost-effective type of a virtualization is the full virtualization, whereas the enhancement technique is the para virtualization. Guest OS calls are separated from the physical layer, whereas here it is not been separated. Allows guest to execute independently, but here it is not like that. It has to go through the hypervisor. All these points are taken from those particular concepts, whatever we have studied. Guest OS issues privileged OS calls directly to access the hardware. Here it is being sent through the hypervisor. Low performance, high performance. You may wonder here during just before explanation, I just gave you only few differences, but here I am putting those differences. The number of the differences are more. Why more? If you carefully observe certain statements there, most of the couple of differences describe the same concept but are put in different manner. Why? Because in order to get more number of marks in as point of your point of examination. That's it. If a question appears for a 5 marks, or if for 10 marks, in 10 marks it could be that what is virtualization, what are the types of explain types of virtualization with differences. So you just need to talk about what virtualization is, then the what we mean by full or virtualization and para virtualization with the diagram, and then this particular difference table. In that difference table, they may expect it to be of a 5 marks. Marks distribution will be 1 mark for full virtualization, the definition that is 1 mark for the virtualization definition, 2 marks for full virtualization in that a definition and a diagram is covered, and 2 marks for the para virtualization definition and with the diagram, and 5 marks for the differences. Okay, I am in this particular semester, this subject, I will explain the concepts along with giving importance to your examination, because I want you all to score good number of marks in the subject. Any doubts, students, in the virtualization? See, I did not go in detail again explaining the same stuffs because I have done that during the diagrammatic explanation. Any questions, any doubts?